Everyone, welcome to this particular session. This is a problem related to block friction, and earlier problem I had solved a block friction problem wherein the blocks have been placed one over each other and which have been placed on the horizontal surface. And now in this particular problem there are two blocks here. The weight of first block is 300 Newton, which has been placed over the second block, which is of weight 900 Newton. Both have been placed over the inclined surface, which is theta. So this is what is the given statement of the problem diagram, and we'll look at the statement of the problem now. Now statement of the problem says is what should be the value of theta in figure. So theta value itself should be determined. So this itself is nothing but the unknown parameter. So theta itself should be determined. So what we need to determine is the value of theta. So which will make the motion of the block 900 Newton down the plane to impend. So this particular block 900 Newton moves in the downward direction. Down the plane means it will move in the downward direction. That is, direction of impending motion of the block 900 Newton is downward. So we need to adjust this particular theta in such a way that 900 Newton block does not move downward. That means it should not slide down the plane. There is no element which has been connected to 900 Newton block. If I had this string which has been connected to 300 Newton block, the same string happened to be connected to 900 Newton block, then there is no question of adjusting the value of theta, because the string itself will ensure that 900 Newton block will not slide down the plane. Since it is unsupported, 900 Newton block is unsupported, it has not been connected neither by string or nor by any external force. For that reason, 900 Newton block on its own weight will try to slide down the plane. So when it tries to slide down the plane, we need to adjust in such a way that this 900 Newton block should not slide down the plane. If this particular 900 Newton block slides down the plane, obviously 300 Newton block will have a failure from its original position. For that reason, to ensure this total system should be kept under equilibrium position, it is very much essential to see that this particular theta will plays an important role in adjusting this particular 900 Newton not to allow this particular block to move down the plane. That means, as the statement of the problem itself says that 900 Newton block will move down the plane. Because of its own weight, the block will move down the plane. There are two reasons here. One is that it has not been connected by any external agency. There is no any external force. So obviously the block has to move in the downward direction. So on its own, it will never try to move along up the plane. Reason, there is no any external force. Due to the gravitational attraction force, the block will always try to slide down the plane when it is unsupported. The question for 300 Newton will not arise. Reason, 300 Newton has been connected with a string. For that reason, since it has been connected with a string, 300 Newton block will not slide down the plane. On the other hand, 300 Newton block will be held in intact portion because of the string that has been connected. So since 900 Newton block is an unsupported element, it will try to slide down the plane. First reason is it is not supported. Second reason, because of the gravitational attraction, it will move down the plane. So we are supposed to find out the angle theta. The coefficient of friction at all contact surfaces. The coefficient of friction for all contact surfaces is 1 by 3. So here the coefficient of friction for all contact surfaces is 1 by 3. So here the coefficient of friction between 300 and 900 is 1 by 3. Similarly, coefficient of friction between 900 and the surface is 1 by 3. So we are supposed to find out. So that is the coefficient of friction is been mentioned now. So to begin with the solution, there are few steps that we need to follow. First one is to draw the free body diagram. So free body diagram is nothing but the isolation of the body which is in contact with the surfaces and then represent all the forces acting on the body. Second one, there are three rules that we need to follow. So first rule is self-weight will be always vertically downward. That is, it will be parallel to the conventional y-axis. Self-weight will be always vertically downward. Then reaction or else normal reaction N will always make an inclination of 90 degrees to the plane of contact. So whether it is horizontal surface, Whether if it is horizontal surface, reaction will be perpendicular. If it is inclined surface, reaction will be perpendicular to the inclined surface. That is what is the third condition. Fourth condition is frictional force will be always opposite to the movement of the body. So here, movement of the body, there are two conditions here. 900 Newton block will move downward. So as a resultant, frictional force will be in the upward direction at both the junction. So because here also you have a coefficient of friction, obviously frictional force will be generated between 300 and 900 Newton block. So here, since the block moves downward, so frictional force at both the surfaces will be along up the inclined plane. So to begin with the solution here, first we need to draw the free body diagram. As stated, free body diagram is nothing but the isolation of the body which is in contact with the surfaces. So if I isolate this particular body now isolation of the body means we need to separate this particular body. First body which is of block 300 Newton. So 300 Newton block is placed here, below which is a 900 Newton block which will be drawn in this particular fashion. Now 300 Newton block is been connected with a string now. Now if you remove this 900 Newton block, 300 on its own will move downward. So now the tendency of this particular block to move downwards is not possible because of the string which has been connected. So what it indicates, string will offer a force towards the right hand side. This is the reason why this T will be shown in the upward direction. So the main function of this particular string which has been connected is not to allow this particular block 300 Newton to move downward. So not to allow this particular 300 Newton to move downward, the resistance should be in the opposite direction. So it will be shown in the upward direction. Then next we need to show the coordinate direction. So coordinate direction can be shown in two ways. One will be either conventional x-axis and conventional y-axis. The other one is the inclined x-axis and inclined y-axis. Now here we shall prefer to have an inclined x-axis and inclined y-axis. Purpose behind that is, it is always better to show the conventional directions along the direction, whichever direction the body tends to move. If the body had to be placed on the horizontal surface, there is no point in noting down the coordinates along inclined direction, because if a body has been placed on the horizontal surface, the body will obviously move along the horizontal x direction, or it will have a tendency to move along the vertical y direction. For that reason, when a body has been placed on the horizontal surface, the conventional direction that has been chosen is horizontal x-axis and vertical y-axis. Now since both the blocks have been placed on the inclined surface, so we'll try to have the axis which will be along the direction, whichever direction the body moves now. Since this particular body, if the string is not been connected, it will move along parallel to the inclined plane. We'll try to opt an axis parallel and perpendicular to the inclined plane. So parallel to the inclined plane means this is an inclined plane. Parallelly, if you shift it, this will be the x-axis that we are going to prefer now. That is inclined x-axis that we are going to prefer. Likewise, perpendicular 90 degrees, if you parallelly shift here, the inclination between x and y will always be 90 degrees here. Now, as per the rule, self-weight will be always vertically downward. So self-weight here shall be shown in the vertically downward direction like this. And the self-weight of this particular block is 300 Newton. So which will be shown in the downward direction. Because of the gravitational attraction force, the self-weight will be always shown in the downward direction. Now what shall be the inclination made by this particular 300 Newton force now, that is 300 Newton weight. If you extend this particular line here on the rear side, the inclination here is theta. So obviously the inclination made here will also be theta. This inclination will be theta. The inclination between x and y axis is 90 degrees. Likewise, the inclination between 300 and the horizontal axis is 90 degrees. This remaining inclination shall come out to 90 minus theta, and this will be again an inclination of theta. Reason why this is 90 degrees, because inclination between x and y axis is 90 degrees. 300 Newton, which is self-weight, will be always vertically downward. When it is vertically downward means it is parallel to y-axis. So for that reason, it is parallel to y-axis, and this is perpendicular to the horizontal surface. So inclination between both is 90 degrees, and the left out angle will be 90 minus theta. Likewise, if I mention inclined x-axis and inclined y-axis, inclination between both is again 90 degrees. If this angle happen to be 90 minus theta, then the other angle with respect to y-axis shall be theta. So if you consider only this particular force, which is 300 Newton force, which will make an inclination of theta with respect to y-axis. So theta will be the inclination made by 300 Newton force with reference to y-axis. Now if we happen to resolve this, the resolution force component will be horizontal force component left hand side, vertical force component downward. So to this theta, this is opposite. So it shall be called as 300 sine of theta. And this will be 300 cos of theta. Because to this theta, this is opposite. So sine of theta. So if this is opposite, this has to be adjacent. So this has to be cos of theta. So this will be the forces for the inclined force, that is 300 Newton force, when it is to be resolved along horizontal direction, that is along the inclined x direction, which will be 300 sine theta, and perpendicular to the x axis, which will be 300 cos of theta. Now to resist this, there will be a reaction that will be generated here. That reaction will be in the upward direction, what we will call it as N1. Further, this N1 will be transferred where? It will be transferred to the block of weight 900 Newton. So N1 is the reaction that has been transferred. In addition to N1, 900 Newton force will also be transferred in the downward direction. So how it will be transferred in the downward direction is, again, you need to draw inclined x-axis, inclined y-axis, and 900 Newton force will be transferred in the downward direction. Now here, when you transfer in the downward direction, again, the inclination made here is theta. Likewise, the inclination made here shall also be theta. If you transfer the inclination here, this will be theta. Further back, this will be 90 minus theta, and this again shall come out to theta inclination. If I separate only 900 Newton now, 900 has been placed here. The inclination here shall be 90 minus theta. Here, it shall be 90 minus of theta, and this inclination will be theta. Now this 900 Newton again needs to be resolved now. As the force is inward, other two directional forces shall be inward, and this will be horizontal force component and vertical force component. Horizontal force component will be 900 sine of theta, and vertical component will be 900 cos of theta. Because to this theta, this is opposite, so sine of theta. To this theta, this is adjacent, so this will be cos of theta, so 900 cos of theta. To resist both these forces, there will be a reaction force component called as N2. So this will be the reaction, that is the self-weight and the reaction force component that has to be shown here now. Now to show the direction of the frictional force. To show the direction of the frictional force will be opposite to the movement of the body. Now what direction it has to be shown now? Now here, as stated, the block will move down the inclined plane. So the moment of the block is down the inclined plane. Frictional force will be upward. So this frictional force shall be shown in the upward direction. So which will be called as F of F1. Similarly here it will be F of F1, because this will be the frictional force between block of 900 Newton and block of 300. If this is upward, this frictional force will be downward. So here I shall call this as F of F2, F of F2, and this will be F of F1. So here if I call it as F of F1, this will be F of F2. Here F of F2 will be mu times of N1, and here it will be mu times of N1. Whereas F of F1 will be mu times of N2. Because this will be the frictional force between N2 and frictional force. This will be the frictional force between N1 and the frictional force. So it will be called as mu times of N1. And mu value has been given as 1 by 3. So this is nothing but the free body diagram that we are going to draw. So first we need to isolate the diagram and then show the self-weight downward, which will make an inclination of theta. Now after separation, 900 will have 900 sine of theta, which is parallel to the inclined plane, and perpendicular to the inclined plane will be 900 cos of theta. Likewise, 300 will have parallel to the inclined plane as 300 sine of theta, and perpendicular will be 300 cos of theta. Now frictional force here will be shown in the upward direction because the block tends to move along down the inclined plane. Then frictional force will be opposite. As this is dependent on N2, so this will be mu times of N2. And this frictional force is dependent on N1, so this will be mu times of N1. So if we start to solve here, for block of 300 Newton, block of 300 Newton. If I start for this particular block now, if I separate the forces here, if you happen to check out here, summation of force along, I shall separate only block 300 Newton. Draw x-axis, y-axis, 300 Newton force, and this is inclination theta. Frictional force here is shown downward, and the name of the frictional force is F of F2, which is mu times of N1, and N1 is upward here, and this is 300 Newton. To this particular block you also have a string T that has been connected. Now if we happen to solve here, now mu times of N1 means it is 1 by 3 times of N1. So I shall take summation of force along y direction is equal to 0. If I take summation of force along y direction is equal to 0, to this theta, this side is opposite. So this will be 300 sine of theta. And this will be downward, which will be 300 cos of theta. So if we solve this, summation of force along y direction is equal to 0, minus 300 cos of theta, minus because it is downward, plus N1 because N1 is upward. I shall not consider F of F2 because it is parallel to the x-axis. If it is parallel to the x-axis, so I shall be considering only forces parallel to y-axis. So for that reason, F of F2 and T shall not be considered. So N1 will be equals to 300 cos of theta. So keep this equation as it is. Name this as equation number 1. Further proceeding, we have a relation for F of F2. So F of F2 will be equals to mu times of N1. Mu value has been mentioned as 1 by 3. That is coefficient of friction at all contact surfaces 1 by 3. So if I substitute this 1 by 3, N1 value is 300 cos of theta. As a resultant, this will be 100 cos of theta, which will be the value of F of F2. So keep this equation as it is because this is also an unknown parameter. Name this as equation number 2. Further, take summation force along x direction is equal to 0. If you take summation force along x direction is equal to 0, x direction means along inclined plane, If I take forces parallel to the inclined plane, you have force F of F2 towards downward direction. Downward direction will be negative, so minus F of F2 plus of T because it is upward, that is equal to 0. So T is equal to F of F2. F of F2 value is already known. So substitute here. T will be equals to 100 cos of F of F2. Then this value 300 minus 300 sine of theta, that is equal to 0. So if I reframe this equation, I shall write it here. T will be equals to 300 sine of theta plus of F of F2, which will be 300 sine of theta plus 100 cos of theta. This will be the value of T now. This 300 sine of theta means summation of force along x direction is equal to 0. F of F2 is downward, so minus. T is upward, so positive. Then here you have a force component which is parallel to the inclined plane. And since it is left hand side, so this will be minus 300 sine of theta, that is equal to 0. Keep T as it is on the left hand side. If 300 moves towards the right hand side, plus 300 sine theta. Likewise, if F of F2 moves towards right hand side, plus of F of F2. So 300 sine of theta, F of F2 value is already there, 300 cos of theta. So name this particular equation as equation number 3. As of now, we don't have any solution for this. Keep this as it is. Then proceeding to 900 Newton block now. So if you proceed to 900 Newton block, I shall draw that particular diagram of the block again. If I redraw the diagram of the block again, the 900 Newton block will descend in a downward direction. So show x-axis and y-axis. 900 Newton block, self-weight will be always vertically downward. This will make an inclination of theta here. If this makes an inclination of theta, so it will have an inclined force component which will be 900 sine of theta, and vertical force component will be downward, which will be 900 cos of theta. At this junction we have a frictional force, and that frictional force will be upward. Reason shown in the upward direction here is because the block descends in the downward direction. So frictional force is shown in the upward direction, and name of the frictional force is F of F1. So F of F1 here is mu times of N2, wherein N2 is a reaction that will be between block of 900 Newton and the ground. Likewise, frictional force here will also be in the upward direction, and that frictional force will be F of F2, which is mu times of N1. Now this F of F2 is already been calculated. F of F2 is 100 cos of theta. So I can substitute here F of F2 is 100 cos of theta, which is already been calculated. So this value is already been calculated, which is 100 cos of theta. Now we need to find out the angle theta now. So apply summation Fy is equal to 0. If we apply summation Fy is equal to 0, this will be 900 cos theta is downward, so minus 900 cos of theta downward. In addition to that, you also have N1, which has been posed in the downward direction. Now what is N1? N1 is a reaction that will be developed due to 300. So here N1 is upward. When it transfers to block to 900, it will be in the downward direction. So here this particular N1 will also be in the downward direction, minus of N1 plus of N2, that is equal to 0. N2 will be in the upward direction, N1 is downward, minus 900 cos theta will be downward, minus. So N2 will be equals to N1 plus of 900 cos of theta. Now what is N1 value? N1 value is already been known, which is 300 cos of theta. If I substitute here, N1 will be 300 cos of theta plus 900 cos of theta. So which will be equals to N2. So N2 will be totally, I can take cos of theta common outside. What is left out is 300 plus 900, which will be 1200 cos of theta. So this is equation number 4, because 1, 2, 3 is already considered for block of 300 Newton. So keep this as it is. So F of F1 is mu times of N2, which will be equals to 1 by 3 1200 cos of theta, because mu value is 1 by 3. So as a resultant, this will be 400 cos of theta will be the value of F of F1. So this will be the equation for F of F1. This is, you call it as equation number 5. Then you take summation Fx is equal to 0. So refer back to this particular diagram. If you apply summation Fx is equal to 0, F of F1 is upward. So you are going to write it as positive. Then likewise F of F2 is also upward. So you are going to write it as plus of F of F2. Because both are upward, so you are going to write it as positive. On the other end, 900 sin theta is downward. So you are going to write it as minus 900 sin of theta, that is equal to 0. So F of F1 is 400 cos of theta. F of F2 is 100 cos of theta. F of F2, which is already been calculated here, as 100 cos of theta. So substitute here plus of 100 cos of theta. Then if you take this on right hand side, this will be 900 sin of theta. So total value will be 500 cos of theta, which is equal to 900 sin of theta. So which will be sin of theta divided by cos of theta, which will be 500 divided by 900. So sin of theta by cos of theta will be tan of theta is equal to 500 divided by 900. So 500 divided by 900, which will come out to 5 by 9, shift tan inverse. So angle theta will be coming out to 29.05. So this will be 5 by 9. So tan inverse of 5 by 9 will come out to 29.05. So this is the inclination of theta. So that is what has been asked now. If I want to find out t now, t value is there now already. If you want to substitute here, substitute 300 sin theta plus 100 cos theta, which will be 300 sin of theta plus 100 cos of theta. So if I substitute this, 300 sin of 29.05 plus plus 100 cos of 29.05. So as a resultant, T value will be 233.09 Newton. So this is how we are supposed to find out. Main important thing is to find out the inclination theta. So this is how the solution will start. First we need to draw the free body diagram. Next we need to place self weight in the vertically downward direction. So whatever is the inclination theta that has been made here, the same inclination theta will be transferred here. This will be 90 minus theta, again coming back to theta. This 900 will be resolved along the horizontal direction. This is theta. To this will be sine of theta, opposite side, and this will be adjacent, cos of theta. As it is 900, so this will be 900 sine of theta and 900 cos of theta. So taking summation force along y direction, 900 cos of theta is downward, so minus 900 cos of theta. N1 is also downward. N1 is the reaction. N1 is the reaction from reaction of 300 Newton block. 300 Newton block. So that is also in the downward direction. Plus of N2 is equal to 0. So N2 will be equals to, keep N2 as it is. When this shift towards right hand side, it will be positive. Likewise, on 900, which is negative on left hand side, when it shifts towards right hand side, it will be 900 cos of theta. So net value of N2 will be 1200 cos of theta. So frictional force relationship is mu times of N, where mu is the coefficient of friction. So frictional force here will be 100 into normal reaction 1200. So it will be 1200 by 3 will be 400 cos of theta. So considering summation of force along x direction, as both these forces are upward, you are going to consider this as positive. Whereas 900 sin theta is downward, so you are going to consider it as negative. So 400 plus 100 will come out to 500, and this will be the value of theta that is required to calculate. So what should be the value of theta? So the value of theta here is 29.05 degrees. So that is what is the answer that we have calculated. Thank you. Have a nice day.